Hello again. Today we're going to be solving a different type of DEs, and this is where the power of DEs really comes in. Solving DEs of the form, drum roll please, dy by dx. We've been solving functions of x up until now with this, but what happens if it's a function of y? A very, very different scenario. So we're looking at what happens here. Now, because x is our operator function here, is our independent variable, we can't do this. We can't just go, therefore y equals the integral of f of y dx. It doesn't work because you've got a function of y and you're integrating with respect to x. So this does not work. And so it's like, for an example, how do you do sine y dx? Like, what is that? Doesn't make sense. Okay, function of y dx, don't know. So what we do is none of that, obviously. What we need to do is actually get, because we've got a function of y, we want the independent variable to be y. In other words, we want y to be on the bottom here. So what we can do is flip that upside down and have dx dy equals, and we've got to flip this side upside down as well, 1 over f of y. And once we've done that, now we can actually integrate it. And so what we get is that x is equal to the integral of 1 over f of y dy. And then you have got the situation you want. You've got a function of y and integrate that with respect to y, and you're all happy. And so if you've got a function like this that's a derivative difference equation, sorry, I'm getting muddled up, as a function of y, what you need to do, flip it upside down and solve for x. Once you've solved for x, then you can rearrange this in terms of y to get the general solution. And then you can use points to find a particular solution. Let's go into this. This is where it gets a bit hairy sometimes, but you just got to hold on to your hat. So let's just have a look at an example. Let's just go straight in. Let's have a look at this. Dy dx is equal to 2y plus 7, whatever, something like that. So how do we do it? Well, let's flip it upside down. Okay, I'm going to go across so I might run out of space. No, this one shouldn't take too long actually. So dx dy equals 1 over, we're going to flip both sides upside down and we get to this stage. And so therefore x is equal to the integral of 1 over 2, whoops, pardon me, you didn't pick me up on that, it should be 2y plus 7, sorry. So therefore x is equal to the integral of 1 over 2y plus 7 dy. Fantastic. Now we know how to do this, we can integrate that, so we're all happy. So that's equal to, what is it equal to? It's a linear term on the bottom, so we can take the log of that. That'll be a log base e of 2y plus 7. And because there's a 2 in front of there, we need to divide by that 2, so it'll be half log e 2y plus 7 plus c. And that's what your x is equal to. So for x is equal to that. Now that's not the solution. Don't be fooled. That's not the solution. Remember, what we're after is what y is equal to. We want the solution to be y equals something. So what we just need to do is rearrange this. Okay, so let me rearrange this. So therefore, x minus c is equal to a half log e 2y plus 7. Now I'm doing this one step at a time. Normally I do this about 5 steps at a time. And you can too. Times it by half, so times both sides by 2. X minus c is equal to log e modulus 2y plus 7. That modulus is important. Don't go missing those. Fantastic. Take exponential of both sides, so therefore you get e to the 2x minus c is equal to 2y plus 7 modulus of. Therefore, now this modulus, we can't just remove that modulus, we need to actually deal with it. And so what we've got is, this could be positive or minus over here because we've got the modulus here. So what we need to do is go plus or minus e to the 2x minus c is equal to 2y plus 7, and then I'll just solve it now. So I'll move that. So move the 7 across, just subtract 7. So I'll just do it. Y is equal to, so minus 7 plus or minus e to the 2x minus c, and that's going to be all over 2. Like that. That is your general solution to that. Okay, general solution there, and there you go. We don't know if it's plus or minus. It could be either, and the only way that you could find out whether it was plus or minus is by a given point, and that will tell you whether it's plus or minus. This differential equation here, it could have a solution of plus or minus, and we don't know what c is equal to either. But a given point will tell you both of those things in one go. Okay, so so very good. If the question did say something like y was greater or equal to 0, let's say the question said that, then here you would know 2y plus 7, therefore that is positive. You could just remove the modulus there and not have to worry about the plus or minus. But if you're told nothing about y, you must continue on and let as a plus or minus. Okay, so there's just some things to be really careful about when doing DEs. Okay, let's just do another one. I'll do a given point one. Let's just something simple. I just want you to get used to this format. Y plus 1 given that y4 equals 0. Let's have a look at this. Again, you don't need to do the whole flip it upside down. You can go straight to the fact that x is equal to the integral of 1 over y plus 1 dy, which is equal to log e y plus 1, like that, plus c. So that's what x is equal to. Okay, so move the c over to there, that becomes x minus c. Take the exponential, so that would be e to the x minus c is equal to the modulus of y plus 1. Therefore, plus or minus e to the x minus c, and then subtract 1, that's what y is equal to. So there is your general solution. Okay, y is equal to that. General solution. Okay, but we've been given a point. So let's bring this in now. Let's bring that point in and see whether it's plus or minus, and let's see whether it's what am I saying here? What the value of c is equal to. Now I just want to show you something. So therefore put the value in. Y is equal to 0 is equal to plus or minus e to the x. X is 4 minus c minus 1. Now, can you see how this looks messy? For solving for c here, this is going to be horrible. So this is actually doesn't help you very much. This is hard, messy to have a look. For c, imagine this, you move the 1 over to this side, you've got plus or minus, you've got this, it's horrible. What a better point to do it is, instead of doing it down here, it's to actually sub in there, at this point here. You can see that the c is by itself, it's not sort of trapped within this, and so it's much easier. So let me just back the truck up again. Let's have a look at this again. So if I had have figured out c at this point instead, the question becomes much easier. You're not dealing with logs and anything like that, you'll be dealing with much nicer numbers. So let's have a look at it. So let's go. So therefore x is equal to that. The value of x is 4. 4 equals log e, the value of y is 0 plus 1 plus c, and we just need to solve this for c. And you can see how easily this drops out. This is log e of 1. Log e of 1 is 0, so that just cancels out there, and that tells you that c is equal to 4. Easy. Okay, that's just getting used to knowing how these things work, and this is just practice. So c is equal to 4. So therefore we have x equals log e modulus y plus 1 plus 4. There's your general solution. Okay, fantastic. Now we need to just rearrange this. So therefore, again we'll do this. We'll have x minus 4, we'll have e to the x minus 4 equals modulus y plus 1. Therefore, we will have y is equal to plus or minus e, so we'll have plus or minus e to the x minus 4 minus 1. That'll be your solution. Now, at this point, you go, well, is it positive or minus? We don't know, do we? Well, again, just check your initial values here, okay? We've got this up here, y of 4 is equal to 0. If you substitute in x is equal to 4 into here, what do you get? You get e to the 4 minus 4, that's e to the 0, so that's 1. This must be equal to 0, so therefore it has to be positive. So it needs to be this positive solution. So just check it once you get down to this point. So we get to this point and you say, therefore, y is equal to e to the x minus 4 minus 1. There's your solution. It checks out with this initial condition. If that was negative, that would not work, because you get negative 1 minus 1. That would be equal to negative 2, not 0. So that's not right. It must be positive. That is your particular solution. Okay, so there you go. That's how to do it. Things to be careful of is your moduluses with your logs and your e's. Get used to that. Be really careful. Know when to find out your integration constants. It's often easy to do it when they're by themselves. See that they're lonely here. This is a good time to get them when they're lonely, rather than them being sort of caught up in, where was it? I rubbed it out. But caught up in e's and that sort of thing, because you need to go into logs. Have fun.